Hello everyone, this is EE101 channel, sharing industrial news and knowledge about residential and commercial PV inverters. I'm Rachel. Today we are going to talk about solution for grid voltage to high or over. Australia has reached a historic milestone. The installed solar capacity has reached 25 gigawatts. The Australian Photovoltaic Research Institute API pointed out that Australia has the largest per capita solar energy installed capacity in the world. In addition, in view of the large proportion of residential photovoltaic in Australia, there has been a distinct dark-shaped demand curve. That is, at the peak of photovoltaic power generation at noon, the demand drops, and the peak of power consumption occurs in the morning and evening where there is no light or weak light. Then, let's study the principle of voltage. Voltage is equal to current times resistance. Voltage is a channel container used to allow current to pass through, so it must be attached to the conductor. There is another thing in conductors, resistance. The resistance is like a rubber band which tightens the voltage container and prevents the current from passing through. The factors affecting the resistance are the material, length, cross-section area, and temperature of the conductor. When the material and cross-sectional area are the same, the longer the conductor length, the greater the resistance. When the material and length are the same, the smaller the cross-sectional area of the conductor, the greater the resistance. When the length and the cross-section area are the same, the conductor resistance of different material are different. So the larger the cross-sectional area of wires of the same length and material, the greater the allowable current. Because the resistance is small, it also means that the voltage of wires with large cross-sectional area is greater. Refer to the above formula because of the current is large and the resistance is small. Therefore, when it is necessary to transport power for a long distance, the cable must be very thick and the voltage is very high, so that the current can flow steadily to our distributor. Then you may have a question. What is the relationship between that and excessive grid voltage? After we understand this principle, we can look at the current situation of installed capacity in Australia. So many solar energy systems have been connected to the Australian power grid in the past 2 years. Due to the dark-shaped power consumption, all solar energy systems generate the maximum power at noon. At that time, the current is the highest in the day. In order to allow so much current to pass through, the voltage at our user terminal must be increased. When a large amount of current flows into power grid, the voltage at the power grid end will also be increased in order to allow such a large amount of current to flow into the power grid. When the power grid voltage rises to 255 volts for more than 10 minutes or reaches 260 volts, all inverters will automatically shut down. The installer receives a lot of complaint calls every day. Customers at the other end of the phone are extremely angry. My inverter is broken again, and the electric bill is not as low as I thought. So we often find that the electrician will quietly increase the working voltage of the inverter to avoid this customer complaint during installation. Then the inverter will not trip and the cycle stops. If the current is continuously input to the power grid, the voltage of the power grid will become really higher. Therefore, the distributor has made provisions for limiting the current to the power grid. It is feared that the power grid will keep rising in this way, which will lead to the power crisis in Australia. According to the Australian standard AS/NS 4777, the voltage rise between the solar inverter and the street cannot exceed 2%, about 5 watts. So what are the disadvantages of high grid voltage for our users, and how can we deal with them? If the inverter shut down and restarted repeatedly, a lot of power will be lost because it takes time to start up and shut down. If home uses single-phase power, it's more likely to have high and low voltage during peak power consumption. For electrical equipment, this is not a good thing. It will shorten the service life of electrical equipment at home. How to deal with it? 1. If you are able to use three-phase electricity, the three-phase inverter is a better choice. Three-phase inverters have 3 live wires. If a house uses 6 kilowatt inverter, the total output current is about 26 A. If it's distributed to 3 live wires, the maximum current on each live wire is about 8.6 A. If the current is small, the household voltage will naturally become smaller. 2. You can call your electricity distributor to drop down grid voltage from transformer as below. 3. Installers select correct region area when testing and commissioning and adjust to max voltage that is allowed to in correspondence with that area. 4. Use the best inverter brand to avoid misjudge of overvoltage. Install AC cable and breaker properly. Therefore, in terms of inverter selection, we prefer some brands with more powerful and stable performance, such as EH Energy and Solar Edge. EH Energy is more compact in both single-phase and three-phase models. It offers choice, matching the real condition during installation will exclude the possibility of any trip, which can greatly reduce your customers' planned cost to you. In summary, the grid voltage high arrays caused by the popularization of solar energy is indeed a problem that cannot be ignored. That's all.